Section 8.3 is variable acceleration in one dimension. Now just a quick reminder, if you have a displacement, the displacement is basically your position, isn't it, or your distance. Now if that changes over time, what you have is a velocity. So the rate of change of displacement over time, by definition, is velocity. Now if velocity is changing, that is what we call an acceleration. So the rate of change of velocity over time is acceleration, and therefore it follows that if you differentiate displacement with respect to time and differentiate it again, you get acceleration. So that is the second derivative of displacement with respect to time. Now those are all vector quantities, so what we're building up to in section 8.4 and 8.5 is using those things as vectors, as two-dimensional vectors. But it's just worth a quick reminder here of what we did, and it's perhaps worth going back and looking at the videos or doing the exercises from the AS level book on these. In this case, what happens is we get given s in terms of time, for example. So that is a function of time. So if I want to find the velocity, I differentiate and I find the derivative of f with respect to time, and then I can find the velocity at a given time. So if I know the displacement at that time, I can find the velocity at that time, or I can differentiate again and find the acceleration at the time. Now that whole principle I covered in previous videos. The only reason that we have another section here is because this is integrating. To get from acceleration to velocity, you integrate. To get from velocity to displacement, you integrate, and other way around, differentiating. The only reason we need another section is because our integration and our differentiation has got much more sophisticated. If you haven't yet done chapter 9 and chapter 11 of the Year 2 Blue Book, then perhaps this needs to wait until you've done at least chapter 9 and a little bit of chapter 11. But we can now integrate and differentiate things like the one in example 5. So in this case, they give us acceleration is cos of 2 pi times t. So if I wanted to find the velocity, I need to use my A level instead of AS level, techniques. So the velocity is going to be the integral of acceleration, which is the integral of cos 2 pi t, which is going to be 1 over 2 pi sine 2 pi t, because remember 2 pi is just a constant, and don't forget to add on your constant of integration. Now other than that, other than the integration and differentiation being a bit more difficult, everything in these questions is exactly the same as it would have been on the AS questions. So that's all the information you need. Practice the AS questions, practice the integration and the differentiation from the A-level textbook, and then come back to the exercise, and hopefully it will all be plain sailing. Good luck with that.